Alrighty, guys. Last video that goes with factoring these trinomials. It's a specific pattern, and I want to take time to talk about it. We're talking about difference of perfect squares. This is when you have a zero for your linear term, a zero coefficient for your one in the middle. You really only have the first and the third term if you think of it this way. 16x squared plus 0x minus 49. This is what I'm talking about. We have a zero in the middle, so it's not there. It doesn't exist, right? When this happens, that means we get canceled out. And the only way we could cancel things out is if it's exactly the same for both parentheses, except one of them is plus and the other one is negative. Let me show you what I mean. If I'm looking at this one here and I'm factoring this one out, I'm looking at factors of 16, I'm looking at factors of 49 that are the same. I get 4 times 4, that makes 16. I get 7 times 7, which makes 49. So I'm going to put a 4x in the front of both of these parentheses, and I'm going to put a 7 in the back of both of these parentheses. Now, here's the catch. We want these things to cancel out, right? Right now, if I left them as both positive, this would be 4 times 7, the outer, with 4 times 7, the inner. That would be 28x plus 28x. We don't want that. We want them to cancel. We want them to go to 0. So, make one of them positive and make the other one negative. Now you get a positive 28x with a negative 28x, and they cancel out. Plus, it matches with our last term. It was a positive 7 with a negative 7, which makes that negative 49. It's a positive 4 with a positive 4x, which makes that positive 16x squared. So this is the pattern, guys. If you can take the square root of the first term and take the square root of the second term. With a minus sign in the middle, you get this difference of perfect squares. We could take the square root of 16. We could take the square root of 49 because that's 4 and 7. Difference of perfect squares. You need a couple of things for this to work. First off, you need two terms, right? Because you don't want the term in the middle. Second, you need that subtraction sign. It needs to be difference. It has to be minus in there because one of them has to be positive, the other one has to be negative, and the only way you get that is if you have a minus C term. Then you need to take perfect squares of both the first and the last. So let's try again. I have 121x squared minus 64. Can I take the square root of 121? What times what makes 121? The answer is yes, you can. 11 times 11 makes 121. Don't forget your x with it. Now we're looking at 64. What times what makes 64? 8 times 8 makes 64. So I could write this down as 11x plus 8. Close it. Oops. And then I could go, 11x minus 8. Notice, again, it's exactly the same thing. 11x and 8, 11x and 8. But one of them's plus, one of them's minus, and it works perfectly with this pattern, difference of perfect squares. It cancels out that middle term, so you only have the x squared piece and the constant piece. Let me do one more, just to show you how quick some of this can go. I'm looking at 49. What times what makes 49? We saw this one. It's 7. So I'm going to go 7x in one parentheses. Then I'm going to go 7x in the other parentheses. Let's take a look at the constant term. It's a minus 1. Okay, this is kind of easy, right? What times what makes 1? It's 1. So I make one of them positive. I make the other one negative. I'm done. Sometimes people have the question of, does it matter which one is which? The answer is no. Remember, with multiplication, the order does not matter, but the signs do. So make sure you have one of them positive, one of them negative, and you'll be good to go with this pattern, difference of perfect squares. Let me know if you have any questions. We'll talk this thing up even more in class.